This is the screencast for section 6.3, example 4. We're going to eliminate the parameter, yes, again, and identify the graph of the parametric curve. Okay, so first of all, there's going to be two ways that we're going to do this. One is the algebraic expression way, and the other one is the trig identity way. And I'm pretty sure at the end there will be a favorite because one of them requires tons of work and the other one doesn't. But the reason why I want to show you the algebraic expression way is because it brings back some stuff you did in chapter 4, and I think it's very important also because you're going to be using those algebraic expressions as well in calculus. So here we go, the algebraic expression way. So yeah, you would take x equals 2 cosine t and solve for t. So divide by 2, x over 2 equals cosine t, and then the inverse cosine of both sides. So now I could plug that into the y expression. So y would equal 2 sine of not just t, but now the inverse cosine of x over 2. So from chapter 4, if you had the sine of the inverse cosine of x over 2, you could create a triangle, a right triangle, and inverse cosine of x over 2 says that there is some angle whose cosine adjacent over hypotenuse is x over 2. So then by the Pythagorean theorem, this side would be the square root of 4 minus x squared, which means that the sine of theta is now the opposite over hypotenuse, so y would equal 2 times the, let's see, the sine of square root 4 minus, the sine which is opposite, square root 4 minus x squared, all over x, all over 2, duh. The 2's would cancel out. You get y equals the square root of 4 minus x squared, or you can say that that would be y squared equals 4 minus x squared, so y squared plus x squared equals 4. So essentially you're dealing with a circle of radius 2. If you remember that back from algebra 2, it's a circle, center 0, 0, and radius 2. So the trig identity way, much faster. First thing I'm going to do is square both sides of each parameter. So the horizontal parameter is going to be x squared equals 4 cosine squared of t. The vertical parameter is going to be y squared equals 4 sine squared t. Now I'm going to add the two parameters together. So on the left I'll have x squared plus y squared, look familiar, and on the right it's going to be, let's see, 4 cosine squared t plus 4 sine squared t. If I factor out the 4 on the right side, I am left with a trig identity. Cosine squared of t plus sine squared of t equals 1. So I have x squared plus y squared equals 4. Now you are welcome to use either way. If this is the way you go to, that's fine. It is a little bit more work. If you have trouble remembering trig identities, if you remember to square both parameters first and go the trig identity way, by all means go ahead. For the now try problem number 23, I'm going to do the short, easy way. I'm going to square both parameters to eliminate, I'm going to square the horizontal and vertical expression. 25 cosine squared t y squared equals 25 sine squared t. And then I'm going to add them together. So x squared plus y squared equals, this would be 25 cosine squared t plus 25 sine squared t. Factor out the 25, which means I would have a circle centered at the origin of radius 25. Whoa, radius 5, sorry.